Welcome back, everybody. In today's video, I'm going to be explaining to you the differences between public and IP addresses in our modern networks. Alright, so to start out, this is going to be obviously IPv4 addresses. IPv4 addresses are the much older standard, developed long before the turn of the century, millennia, whatever. And so IPv4 addresses are very limited. There's a certain number of them. Obviously, you only have your 4 octets. That's each section before the dot. It's called an octet, and there's only a finite amount of numbers that can be there. And of course, you can only use numbers, you can't use letters, you can't use anything else. So IPv4 addresses are inherently limited. In the old days of the internet, it used to just be that every device on the internet that was connected to old ARPANET or whatever would just all have their own IP address. They would just be sometimes random. It would really depend on a lot of things what the IP address would be. But the issue obviously ran into that when more devices started coming on the internet. They ran into the issue that they were running out of IP addresses for all these new devices. So that issued in private and public IP addresses. And basically what a private IP address is, so you have your ranges of IP address from 1.1.1.1 to 999.999.999. whatever. Right? You have your entire range. And what private IP addresses are certain reserved ranges of IP addresses. Right? And right here, I'm using this website. This is geeksforgeeks.org. I'll leave this link in the description. I'm going to be using this website little list to go and talk about some things. So this is the range of public IP addresses that can be used in private networks. There are many other IP addresses that are reserved. There's, let's say, your loopback, which is your 127.0.0.1, but these are the IP addresses that can be used on your private networks. So the 10.0.0.0 is a /16. The 172.16 is a /something else /20. Don't quote me on that. And then the 192.168.1.1 is a /24. And so yeah, it is interesting how they've kind of broken them up. I think it was the IEEE that did this. They broke them up into having different subnet masks, different sided notations, and different networks that are designated. So theoretically, you could have a public IP address be 192.169.1.1, but 192.168.1.1 be private. So hopefully that just gives you some background. Now we're going to go down the list. It's a good list here. So we have number 1, your scope of the private IP is local, scope of the public IP is global. So this means, actually, we can go to number 2. Go right to number 2. It is used to communicate within the network. All right, and what that's and this one says used to communicate outside the network. What this refers to is your network, the network that you control. So your private IP addresses are used to communicate within your network. You control it. You can decide what has what IP address, right? And you're communicating within your scope of being a network administrator. So you control every device on it. It's your network. It could be in your home. It could be in your office. It could be in your workplace, wherever. Public IP address is used to communicate outside of the network, meaning the internet. The public IP address is always used to communicate on the internet. Now, the way that it gets communicated on the internet, we can get into BGP and all the other protocols used. Obviously, you have your internet service provider. That is typically how you communicate with the internet. Typically, your internet service provider will give you one or multiple IP addresses depending on what you pay for, and that is your public IP address. We'll get into NAT, network address translation, in a second, but moving on to number 3, private IP addresses of the systems connected in a network differ in a uniform manner. Public IP may differ in a uniform or non-uniform manner. Basically what this means is that on your private network, you have complete control over everything, and you get to choose what devices have what IP addresses, and it could be a very specific range of things. Could be for this or that. I'll give you an example. 192.168.1.1, most common default gateway in the world for private networks, of course. And you don't necessarily have to have .1.1 as your default gateway. It's just that's a standard, and that's a uniform standard and habit that people adopt, and that's of course what a lot of routers have as default is 1.1. And you could also typically if you have like one router, one switch, it'd be .1 is your router, .2 is your switch, and people will also do it at the end. They'll have like .254 or .253 as their switch. And then public IP addresses, because it's controlled by the ISP and because the numbers that the ISP gets are are allocated by a agency or a government control or whatever, it may just be completely random. You may just get a random IP address. Whereas with this one, you can control it on your own network. Number 4, it only works on LAN. It is used to get internet service. I'm starting to wonder if this website was written by people who don't know English too well. But yes, your private IP address will only work on your LAN. If you try to enter a BGP entry, for example, which is Border Gateway Protocol, that's the routing protocol of the internet. If you try to enter a BGP entry with a private IP address, it just won't work because private IP addresses are private. It is used to get internet service. Yeah, technically that's true. Technically, you can't get onto the internet without a public IP address. That is 100% true. It is used to load the network operating system. It is controlled by ISP. I do believe that this website was written by somebody that doesn't quite know English too well. I'll translate. If you're the owner of this website, I will help you translate this. Although it is kind of funny. It is available free of cost. This is 100% true. You can make as many private networks as you want. I have probably 5 or 6 private networks running in my home lab rack. You can make infinite private networks with infinite numbers of IP addresses. You don't have to pay anything. It's just you configuring it. Public IP addresses you have to pay for because the public IP addresses are owned by internet service providers like Comcast or Spectrum or Boost or not Boost, any of those. Whoever you have for your ISP, they own that IP address and they are leasing it to you, or sometimes you can buy them if you're like a big entity. If you're like Disney or something, you can buy an IP address. But for most applications, you're going to be leasing it from an ISP. Private IP can be known by entering ipconfig in the prompt. This is true. If you have a Windows computer, you can go Windows R, type CMD, press enter, type ipconfig. You can see what IP address scheme your home is using. This is true. Public IP can be known by searching what is my IP on Google. This is also true. Google will see your global IP address and tell you it. If you're on Mac and you want to see your private IP address, you can do command space terminal and then do ifconfig ifconfig. That's the or ipaddr. All right, moving on to range. These are the private IP address ranges. So you have your /16, /20, /24, and then all of them else are public. This isn't technically true. Technically, you have some little ones like 127.0.0.1. That's your loopback interface. And there's a couple other ones that are like experimental, government sort of things. But basically, effectively speaking, the rest of them are public. It gives an example. So you have 17.5.7.8 and then 192.168.1.10. So this one is private. This one's public. Should be pretty obvious. That one's easy. Private IP uses numeric code that is not unique and can be used again. That is true. Public IP uses a numeric code that is unique and cannot be used by other. So what this is saying is that the private IP addresses are using something that can be replicated millions and billions of times on private networks and it won't interfere with anything. Whereas public IP addresses have to be unique and there cannot be another public IP address in the world, basically. Private IP addresses are secure. Public IP addresses have no security and subject to attack. This is a little bit misleading. Private IP addresses are secure because you could have your private IP address offline. Like you can create a network, sometimes called an air-gapped network. You can create a network that's not connected to the internet and you just have internal access. Public IP address has no security and is subjected to attack. Technically, yes, if somebody has your public IP address, they could theoretically attack you, although most home router firewalls can prevent most attacks. The real attacks these days are more social engineering, getting you to click on a link, ransomware, that sort of thing. Private IP addresses Private IP addresses require NAT to communicate with devices. Public IP does not require network translation. So network address translation. Let me pull up a graphic. Alright, and the last component to this is network address translation. This is technically not part of public and private IP address learning, but it's pretty impossible to understand how the private and public IP addresses interface with each other without understanding network address translation. Basically, NAT, network address translation, translates private to public and public to private IP addresses. And there's a couple different ways that it can do this. It can either have a pool of IP addresses that it has available to use, and when a service on the internal network wants to communicate with the outside network, it will just assign a public IP address to that one private IP address. So if you have a server that wants to communicate to the public network, it'll just assign it a public IP address. But this can you can very easily run out of public IP addresses. So that's for something called PAT. I know it says NAT, but technically this is called port address translation or something like that. And basically what happens is that these services will become translated. So you can see it goes from the 192.168.1.1 to the 101.89.101.12, and then through the internet goes to this host. Now this host could be using a direct NAT mapping, or it could just have its own public IP address. And so you can see that all of these services are running on port 23, and all of these connections coincide. And you can see how the ports also translate. So it starts out being port 96, my light just died, 9688, goes to 8801, and then goes to port 23. Port 23 is likely the service of whatever application these clients are running. And then all these other ports are just generated randomly. Ports are also similarly allocated to IP addresses. Some are reserved by certain vendors, some are private, some are there's all sorts of things. Ports is another topic. But basically you can see roughly how it works. So it translates from the inside private to the inside public. So that is the public IP address that this router has, right? The inside public is the public IP address that the router has. 1.12, see it's 1.12 up here as well, 1.12. And then through the internet, it goes to the outside public IP port. And then this host is the server. The host is not using network address translation. And the router basically allocates port numbers for the applications. If that makes any sense. I'm going to do another video on ports completely. Anyways, that's all for today. Make sure to subscribe. Check out some of the other videos on this channel. This is a new thing. I'm going to bring in one of my friends to help me make some more videos. And that's it. See you next time.